to have a bunch full of interested people here. Thank you also to the pre-talkers for the comprehensive and very important information we received so far. I would first like to introduce myself. My name is Auldia. I currently work for the Helmholtz Environmental Research Center in Germany and in the Department of Conservation Biology. I'm a field biologist by training, a taxonomist and an ecologist, and working on wildlife trade issues since almost 20 years in Southeast Asia. What I'm trying to do now is also bring you down to the ground and see how actually difficult and complex it is to achieve all the national and international requirements to trade species legally. So, a brief outline. You have seen on the first slide, I have chosen a python, the reticulated python. This is the most intense snake harvested for the skin trade in the world. And why I did choose that, I will tell you something about that later on. And then, of course, why is it a long way to go to achieve a sustainable use of that species, and point out complexities and uncertainties of this issue. I will then go on, and as already pointed out by Alison and Marcus, finding or selecting the right indicators or criteria in making an NDF, and that you get a feeling probably not all indicators relate to the same species or species group, showing you again it's maybe more complex than we think. In doing this, I will also outline and present very briefly some more scientifically based methods other than NDFs, which could, in the end, also feed into making a more reliable NDF. And then, of course, if we have the right ones, if we think we have the right ones, and that's an open discussion thing, we will hopefully, if we have time at the end, discuss later. Who do you think should make NDFs? And maybe we can discuss this in working groups. So why did I choose the reticulated python? I already said it's harvested a long time. It's one of the biggest, it's the biggest reptile in the world, actually. And here we see a date like more than 50 years, maybe 70 years. It's a highly lucrative source, and actually the trade did not stop. It was continuous until today. It has a very extensive distribution, I will point out later, which also makes it difficult to monitor and control trade with the species over long term. This will refer to cross-border trade activities which are cryptic, which we cannot, they are disguised. We don't know where skins are coming in, coming out, who is legally exporting their sources, or who is importing or smuggling skins in from range states and exporting them from their country. And of course, having a species with an extensive distribution, you can easily conceal genetic data into other origins, meaning you can export skins from the Philippines, smuggle skins from the Philippines, but export them from Malaysia, and Singapore re-exports them into the European Union. But we cannot trace this really, it's very difficult. We have also, and that makes it also a challenge, numerous stakeholders involved into this business. It's making it a very dynamic situation across all countries. And we have a situation that some countries have developed or identified a new solution to export more species and launder them as captive bred. But the reticulated python to today has not been bred in captivity under a commercial scale, because as yet it's not possible. If we look at the CITES trade database, what Alison just now showed, and we key in the reticulated python, we see that trade has been going on quite a while. And the problem is, what we do not see, that if this trade has gone like 30, 40, 50 years, and CITES was only implemented or established in the mid-70s, the environment around populations of reticulated pythons has changed over time. So this change we do not actually include or calculate to sustainability. So the current knowledge, what we know from partly published scientific papers and internal reports, is although the species is ecologically very flexible, it can adapt very well to man-made habitats, some populations are on decline. So we're looking now here in red the entire geographic distribution of the reticulated python from Assam in northeast India to the eastern, to the Moluccas in eastern Indonesia. Red, we have the nominate form, Python reticulatus, which is involved in the skin trade and to very small amounts in the pet trade. Green is a new identified subspecies in 2002, which is a very colorful form of the reticulated python, and skin traders love this morph for their trade. Of course, they cannot get too many there. But this trade, the skin trade in this region, is not controlled because of this endemic population. And again, before I actually continue, please, I'm feeding you now with information you may need for the NDF later on. So just take this knowledge and sort it out in your working groups later on to make your NDF. The yellow circle here shows a small island, or a few small islands, where another subspecies has been described, 2002. It's a dwarfed form. Like you know, or some of you may know, that some oceanic islands or continental islands, dwarfism and gigantism is a form of geographic isolation. And this is a dwarfed form of the reticulated python, and only included in the pet trade. It ranges only to 2.5 meters. So there's no really, there's no regulation on the spot of that island population. Now, I circled this area. This is the core harvest region of the reticulated python. Most skins come from, let's say, the greater Sundas, Borneo, Sumatra, and Peninsular Malaysia. Smaller amounts come from Thailand and Vietnam, although Vietnam claims a lot as captive prey. Looking at the uncertainties and complex issues in this Appendix 2 species, just a few again outlined. We have a lack of expertise in remote regions, of course. We have over-harvested, we have recorded that in seeing skins of small immature specimens already produced into leather goods. We have partly a poor certification on a local scale, weak enforcement, and the illegal trade. And an Appendix 2 species is more easily to trade illegally, because especially if you have a species where Indonesia and Malaysia together exports maybe 400,000 skins a year, you can easily hide skins and trade these illegally. Now, when I was working for Traffic Southeast Asia a couple of years ago, I did a study on reticulated python and trade in Peninsular Malaysia. And here in red, we have the legal trade routes. The black ones are the illegal ones. some informants were open enough to tell us what's going on. And it's very difficult to get these informants for the study. So here we have a situation, a trade of specimens from the Philippines, but these are actually exported as Malaysian skins to Singapore. And Singapore re-exports them legally to the European Union. And on the CITES export permits, we didn't show now, you have a field called origin, and that's where you put down the country's name. And they chose Malaysia. And actually there should be no trade allowed from the Philippines, so actually these arrows should be black. So this is a very, very well, rough picture of trade routes. It's much more dynamic and diverse. Now, before going more deeper into an NDF, making an NDF, of course science has also produced methods, methodologies, how to look into species, sustainability issues, extinction risks, and so on. And PVA is quite a common method which is still being polished and refined in many ways. And there are few software programs available to identify impact on species and populations. And originally, PAs were developed to identify the extinction risk of endangered species. Here, in this vortex model, we see above the line, it's very, very simple, events. Any events regarding to the species and population in question. Above this line shows an increase of numbers in that population, while below this line a decrease in number. This is a very, very simple figure. I do not want to distract you or confuse you now in showing you this, but to do PVAs, population viability analysis, there are very, very lot of models available. And there are also models available looking at risk of decline, not only in extinction of species. And building these in a scientific manner, the results of these can help also in refining NDFs for scientific authorities in the source countries. And by the way, this vortex simulation model has also been published by the IUCN Conservation Working Group in 2003. So, very briefly, as I said, PVA can describe many events, incorporating probably much more life history traits of a species, together also with management and other issues which are important, essential to consider if the trait is sustainable or not. So what is very important, what you see here, as soon as any new data is available through studies, like what Alison said, the issue is that we need to, condense all the reports which have not been published or which are just shelved somewhere to compile this information to one database and to update information on the species biology and trade management and so on. Now this looks horrible, I know, but this is actually a much older approach, which is actually more economical based. It's about system dynamics. And everything what system dynamics is doing, actually, is identifying causal relationships to each other. And there are a lot of programs doing this, and we have built this very roughly. That's a rough draft. Like, here we have some of the indicators you may have in your NDF later, but much more detailed and not that condensed as you will find them. So we have death rates, we have birth rates, we have survival rates. When do they attain maturity, females and males? This is all about biology. Here we have a bit of trait data included, harvest of adults, proportion of our adults, is there a quota? And again, looking at the quota system, some countries do communicate their quotas with the Science Secretariat, But for Appendix 2 species, it is not obligatory to do this. Malaysia does not do this, for example. When I was in Malaysia and I asked the authorities what annual harvest quotas and trade quotas they have, they didn't tell me. It's something that does not have to be communicated. So again, this is one exercise, and if this is resolved and trade information is included, also building in causal relationships, it can again polish and refine indicators for certain species and species groups to make a more reliable NDF. Now, this all looked very horrible and a bit distracting, but this was just a little bit of science. We already have a lot of data available on the reticulated python. And the problem is, if you remember the geographic distribution of that species, you cannot go into the field and count them. Even a large reticulated python of 6 meters length, you won't be able to find. So you have to identify efficient methods how to mark or capture and mark populations, to identify recapture rates, and then you have probably an index of a population size. But then, if you do your field study in one small region, in Malaysia, in Thailand, in Indonesia, this may not be extrapolated to the entire distribution of the species. More eastern, the population size may be much smaller. So again, it makes it more complex in identifying solutions for the whole species in this big range. So, as I said, we have data, and this basically shows you that pythons eat rats. Pythons eat a lot of rats. But pythons prefer eating rats only until they're 2 years of age, 2.5 meters long, maybe 3 meters, when they shift to larger prey. And commonly, many authorities in the source countries argument we still have enough pythons in our oil palm plantations because there we have a lot of rats. This is true, but some females may only mature at 2.5 meters to 80. The big ones move out. Oil palm plantations, which cover a big realm of that area, do not reveal undergrowth or cleaned up. There's no shelter opportunity. So big ones cannot shelter there. But now the big ones, the big females, they lay a lot of eggs. The bigger the clutch size, the larger the chance that more hatchlings will attain sexual maturity over a certain period. So what you have young females in a man-made habitat, and maybe clutch size between 20 and 25 eggs. You have egg mortality, you have hatchling mortality, and then maybe you have 30, 20%, 40%, it's a guesstimate, of hatchlings that may survive until they attain maturity. But now also traders increase. Although licenses are put out like in Malaysia, every trader can only capture maybe 50 pythons a month. Who controls this? It's very difficult. So, what we have here, we have a lot of data on the species biology. We know when they mature, males and females. In some regions, they reproduce once a year. In some regions, once every 2 years. So that, again, is difficult to measure. The CITES trade database, as Alison introduced, shows you export and import data of species in trade over a certain period you key in, you want to see. And here we have the trade in reticulated pythons from 2000 to 2009. Blue is Indonesia and red is Malaysia. And you see big discrepancies also looking at the country size. Malaysia here has exported more and is much, much smaller than Indonesia. So this is a bit weird. I mean, looking at this figure, something must go on there. It's just not possible that a small country like Peninsular Malaysia, because from Sabah and Sarawak in East Malaysia, the commercial trade in pythons was prohibited during this period. And over time, you see about the average value, how many pythons, wild pythons, not captive bred, only wild, leave both countries for the commercial skin trade. So here you have information you can feed into your NDF. On a side note, some countries still retain in not reporting the number of skins or specimens. They report units like kilo, meters or square meters. And that makes it difficult if a country like Vietnam says 5,000 square meters. Oops, how many specimens are these? Usually we say if they report in meters, well, the standard commercial size for the skin trade is about plus minus 3 meters. So we can roughly estimate if it's a few thousand meters, how many specimens this could be.